Find this again because I failed to read the first couple of times. Give me a second, and it's still working. Hopefully, I'm recording. So the first question, it's an easy question. All we need is the height. So we know that relationship. It's pretty easy. So we can write that x, right? Find that height. We just take the square root of 30 times 24. And remember, we're not writing. We're actually not multiplying 30 times 24. Let's see if we can rewrite that as something with square, perfect square. 5 and 6. 24 is 4 and 6. All right, so I can write that as 5 times 6, which is 30, and the 24 I'm going to write as 4 times 6, right? So we can rewrite this as the square root of 4 times 5, and 6 times 6 is 36. So that's how I'm going to rewrite it. And just to take another step forward, I mean, I'm pretty sure that most of you already have this, but we can also rewrite that as 4, square root of 4, times square root of 5, times square root of 36. Now you can easily understand why this 4 becomes a 2. That 5 is going to stay as the square root of 5. We're not going to change that to a non-terminating decimal. And the square root of 36 is 6. So eventually it becomes 12 square root of 5. Okay, so all these steps you don't really have to show, but as long as just showing it to you so that you can see the transformation from this to its simplified form, 12 square root of 5. Okay. The second question, we want to split it up into two triangles. The first triangle I use is this one, the small one, on the left side. I'll draw it over here somewhere. I'll draw it over here. So sort of looks like this. And this is the 90-degree angle, this is 5, and this is y. So I'm going to write this like this is a short. I'm actually going to write it out. This is a short, and I'm going to write hypo for hypotenuse. And the other triangle that I'm going to use to find that y that's going to help me, it's not going to be the triangle on the right, but better yet, the whole big triangle. Right? So that's the other triangle I use, and I'm going to sort of draw it over here. In that triangle, this is the 90-degree angle. That's the short side. And my hypotenuse is 25. The long, obviously, the long here, it's not really useful to us because we don't even have the value. So we can set up a proportion. And the proportion would look something like this. So on the small triangle, I have the hypotenuse, which is y, and the short, that's 5. On the long triangle, the hypotenuse that matches up with the y is 25, right? And the short side on the blue triangle is y. So cross multiply, y squared is 5 times 25, which is, I'm actually going to leave it at that. I'm not going to multiply it, and you'll see in a second why not. So I'm just going to leave it like that. And then remember, to get rid of that, we're going to take the square root of both sides. So if we do that, hang on 1 second. Ange, give me 1 second. Yeah, give me 1 second. So if you take the square root of both sides, this and this will disappear. And over here, we can simplify that, right? 5 times square root of 25 is the same thing as square root of 5 times square root of 25. That we're going to leave, but the square root of 25 is 5. So our answer is 5 square root of 5. And, Ange, actually, can I call you back in half an hour? Yeah. All right. Okay. All right. I'll call you back in half an hour. Bye. So that's that. Third one. Let's see what we have. So we have the long, we have the short. So right away, I know that I have a lot of information with the long and with the one on the left, but nothing here on the right. Well, I do have, I know that that's 9, so let me fill this in. This is 9. Shoot. I'm going to do this differently. So if I know that's 9, this 9, I know this, I can find out this altitude here, right? So let me just write that as x here, just for a second. So that's height here. It's x. x equals the square root of 9 times 9, right? These two multiplied, we want to find square root. So x equals, and 9 times 9 is 81, and this ends up being 9. So this is also a 9. So the height of this is also a 9. Okay. Now, what we did today, and I'm just going to write this. If this is a 90-degree triangle, this is is called C, the hypotenuse, and this is called A and B, which represents the legs, right? So this is the leg, it's called the leg, this is called the leg, and the longest side, which is the opposite of the 90-degree angle, is called the hypotenuse. And we also briefly talked about that we can use the Pythagorean theorem. So the Pythagorean theorem says that if I take the largest side raised to the second power, it will be equal to the other two sides squared, the sum of the other two sides squared. So I can use that to find this guy over here, Z. Here's a triangle, right? So in this triangle, this is value is 9, this is 9. Let me just change colors for a second. Our hypotenuse, which is the side opposite the 90-degree angle, is my hypotenuse. And we're going to use that, we're going to call that C. Or the Z, we're going to call it C. And the other two sides, A and B. So we can use this Pythagorean theorem to find Z, which represents the hypotenuse. So here we go. C squared, C is the hypotenuse, which I don't know. I know what A and B are, they're both 9, so I'm going to write it as 9 squared. That's 9 squared. C squared is 81 plus 81. C squared is 162. And then we're going to take the square root of both sides. And C is going to be square root of 162, which you can change it to a, what do you call it, decimal. You know, if you have a calculator. I'm just trying to break, let's see if I can break 162 into 2 parts. 162 can be 281, right? So I'm going to write that 162, it's the square root of 2 times square root of 81, and the square root of 1 is 9, so actually we can write it as this, 9 square root of 2. So Z is 9 square root of 2. Okay? And I'm glad we're doing this. This is the other thing we talked about. So we know the relationship. We know that this number, right, that number, is equal to the square root of this times this, right? You look at your notes, that's what we had written the other day. 36 times x. So we can use that to our advantage. And erase that dot here. 36x. So what can we do now to get rid of this radical here? And to get rid of this radical, I'm going to square this guy. And if I square one side, I must square the other side. Now that 2 and this 2 that's hidden that you don't see will cross out, and our radical is going to go away. So all I have is 36x. On the other side, I have 144, because that's what 12 squared is. Divide both sides by 36, and x equals some number. Alexa, what's 144 divided by 36?
144 divided by 36 is 4.
Oh, there you go. So x on this is 4. Okay. So now we have this question. Do we need to find this value over here? This. Let's see if I put that long with this short. So if I draw this triangle out, and I draw this one out, right here. If I draw that triangle out, and get that this is y, that's my hypotenuse, and this is 15, right? Now, if I draw out the other triangle, which is this guy over here, the big triangle, my hypotenuse is 31. My height here is y. And again, I'm going to have a problem here. Redo this. Let's find this side here. I don't think I can do it because I don't know which one's my problem here is that when I mash these two, okay, I don't know if this y here on the big triangle is my long side or my short side, and that makes a huge difference because I don't know if this 15 on the small triangle represents the long and the short side. So I don't have enough information to set up a proportion. I probably will end up setting up the wrong proportion. So what I'm going to do is find this guy over here. And let's call that x. So x is the square root of 15 times 16, which is equal to 4 square root of 15, right? Because that comes out, the square root of 16 is 4. Now let me rewrite this. 4 square root of, what is it? 15. Ah, much easier. I don't even need to do similar problems. Now I'm going to go back to, here's a right triangle, right? This right here is a right angle triangle. And what we can use this. C equals a squared plus b squared. So anytime you have a right angle triangle and you want to find one of the missing sides and you have two of them, you can use the Pythagorean theorem. So in the Pythagorean theorem, C is represented by the longest side. And the other two, I don't know, call this A, call this B, doesn't really matter who's what. Let's substitute. So C squared, my hypothesis is I don't know. A squared is 4 square root of 15 to the second power, plus B, which is 15 to the second power. Right? So let's see what happens here. Now 4 squared is 16. Radical 15 to the second power that 2 is gonna cancel out with that 2 that's inside, so that's gonna come out as 15. And then plus 15 to the second power is 225. C squared equals I can use a calculator. 16 times 15 equals 240. 240 plus 225 and 240, and I'm going to continue over here. That's going to give 465. We take the square root of that. C equals the square root of 465, which I am not going to bother. Actually, should I? We want to change this. We can simplify it. Don't go too crazy here. 465. I mean 5 and 465 divided by 5 is 93. 93 is 3 and 31. Nope, we can't do anything with 465. So C squared root of 65, which on a test they would probably ask you to just find out what the square root of that is, and if I found it on this 465 square second function, apparently it's 21. The y equals 21.56. Okay. What do we want? We want z. Okay, well, seriously? So if this is 28 and this whole thing is 63, 63 minus 28 equals, so we know this is 35 now, right? If we know it's 35, we can use our relationship here to find z, and we know that z is the square root of 28 times 35. And the only thing here we have to do is just simplify. So 28 is 4 times 7, 35 is 5 times 7. Oh, look at that. Let's not rewrite this. 28 times 35 is the same thing as saying 4 times 49 times 5 and multiply with 2 sevens. Okay, so now z is the same thing as the square root of 4. I mean, I'm not going to do that because I don't want to confuse you. So we know that square root of 4 is 2, so that can come out of the radical. Times square root of 49 is 7, that also comes out of the radical. And the only thing that's going to stay inside is the 5. So final answer for square root of 5. And finally, a nice and easy one. Okay, so we got 4 more. That's not that bad. Oh, let's see here. We have so much. So in this question, again, we're going to use this relationship. We know that I know that the height here, 8, this altitude here, 8 equals the square root of these two segments, right? I think I right. 8 equals the square root of 10 times x, right? Or better yet, 10x. Now, can I get rid of the radical? Yes, well, now you know the trick. To get rid of the radical, we're going to square both square both sides. And take this 10x and raise to the second power as well. 8 squared is 64. And if we square that, right, the radical goes away, gives us 10x. And divide both sides by 10, we get that x is 10.4. So now we can use the similar triangles, okay? And I would love for you to use it, or you can now get also practice on the Pythagorean Theorem. So let's work on this triangle right here. So c squared equals a squared plus b squared. We know that 10 is a, the other leg is b, and z squared, our hypotenuse here, right? The side that's opposite the 90 degree, the longest side is c. So if we were to substitute, we would get c squared equals 100, because that's 10 squared, plus 64. And c squared equals 164, or c equals the square root of 164, which most times, I guess, when you're doing, you will actually just type in c equals 164, second function. That's about 12.81 if you change it to a decimal. Or if you want to leave it as in radical form, simplified, what can we change 164 to? So 164 is the same thing as 2 times 82, and this is the same thing as 2 times 41. So you can write c equals 164 as is the same thing as 4 times 41. You'll notice it's the same thing, right? So let me just separate that. That becomes 4 times 41, which is the same thing. The square root of 4 is 2. Square root of 41. So you can leave it like this, or you can leave it like this. Right? Both of them are good. Now we need y. Okay, so for y, I'm going to leave this as 2 square root of 41. Okay, and then for y here, you can again use the Pythagorean theorem, right? Because now we have this big triangle. So again, we have this big triangle, right? Where this is square root of 241. The bottom is 10 plus 10.4, which is 20.4. This is your 90-degree angle. And in this case, you need one of the legs. So this y here would be either a or b, and you can solve it. If you use similar triangles, which I'll do, let's see what we have. Wow, we have so many choices. So let's take that triangle separated. So I'm going to take it separated. That's a y. That's my 90-degree angle. That's 10.4, and that's 8. Let's pick any other triangle. Let's pick the big triangle. So if I use the big triangle, the big one, this is my 90-degree angle. This is 20.4 because the hypotenuse is all of this. This is 2 square root of 41, and this is also y. So pick any two sides. Sorry, that's 41 over here. Let's set up. So on this triangle, y corresponds to 20.4 on this triangle, hypotenuse and hypotenuse. The short side, 8, corresponds with, which one is the short side? 20.4? Let me find out that. 41 second function for each side times 2 equals, the short side on this one is 2 square root of 41. What a mess. Jeez. Well, let's continue since I started. So over here you're going to get that 20.4. So 2 square root of 41y equals 8. So that's 20.4 times 8 equals 163.2, which you're then going to divide by 2 square root of 41 and divide by 2 square root of 41, and God knows what we're going to get there. Y equals, and I'll let you guys figure that out. This was probably actually, not probably, pretty sure it was a bad idea to do it this way, because we could have just used the Pythagorean theorem, and that would have been a lot easier. So in the Pythagorean theorem, c squared equals a squared plus b squared. Remember, c always represents the hypotenuse. So let me show you the triangle. So it's a big triangle, the big triangle. That's 2 square root of 41. This is my 90-degree angle. This side is the sum of 10 and 10.4, which is 20.4. And this y is one of the legs that I'm missing. So when I substitute, I'm going to get 20.4, which is the hypotenuse, right? This is c, this is going to be a, this is going to be b, for example. 20.4 to the second power equals a to the second power, which is 2 square root of 41 to the second power, and plus b squared. And I don't know what b is, and that's going to be my 20.4 times 20.4 times 20.4. So this equals 416.16 equals, that's going to be, so 2 square root of 41 to the second power is going to be 2 to the second power, which is 4. And square root of 41 to the second power is going to come out of 41, right? So we're going to multiply 4 times 41, and that's going to give us 164. So I'm actually going to write 164 plus b squared. We're going to subtract minus 164 here, minus 164 here. B squared is going to stay on that side, and minus 416.16 is going to give us 252.16. And honestly, we're going to take the square root of that. And the square root of 252.16, 252.16, second function square root, equals 15.88. I'm just going to give you a decimal value. 15.88. Nice problem, isn't it? Wow, that's a big problem. This problem right away, let's find what x is. So x is the square root of the product of 15 times 5.4. And because it's a decimal format, let's just, there's really not anything. By the way, that's 5.4. I'm just going to multiply 15 times 5.4, and that equals 80. Really? 5.4 times 15 equals 81. Oh, that's nice. So square root of 81, which x equals 9. Right? So that, I'm going to switch to 9. We can use, to find y, again, you can use the, if you look at this triangle right here, you can use the Pythagorean theorem. With this triangle right here, you have 2 legs and you're missing the hypotenuse, so it's super easy. Because we're doing similar figures, let's do that. So I'm going to use 2 triangles, and the first triangle is going to be the one on the left, where this is y, this is 9, and this is 15. So I'm going to use, and then the other triangle I'm going to use is the big triangle, because I have information there. This is still y, and this is, the whole thing is 20.4. My 90-degree angle. So let's do this. So I'm going to get y on the small triangle, which is the hypotenuse, is represented by 20.4, right? Corresponding. So this hypotenuse is the same as the big hypotenuse, the big triangle. And then this 15, which is the the second, right? The second longest side represents, let's see, represents on that side the y, right? So this and this corresponds to each other. Now we're going to do y squared equals 15 times 20.4, and I'll actually multiply that times 20.4. Hopefully I get a nice surprise, and I get 306. You take the square root of 306. Square root of 306, you can leave it as, take the square root of 306. You're going to get 17.49. But if you want to leave that in a radical format, 306, what's that? Ugh, 306 divided by 2 equals 153. 2 and 153, nothing there we can do. So I'd much rather if you left it like that. Okay. Instead of y equals, what do you call it? The square root of 306. I mean, I have nobody would know what that would equal to. Okay. Is this okay? What can we do here? We can find z with the Pythagorean theorem, right? So focus on this triangle, this one, and this one. This is a right angle triangle where this is C, and this is A, and this is B, right? So although represented by z. So if we write the formula out, c squared equals a squared plus b squared, I know what my hypotenuse is, which is 41 squared. A squared is the 9, so that becomes 9 to the second power. And b, this, I don't know what that is. So 41 squared is some number, which is, I'll continue over here, 1681 equals 81 plus b squared. So this is nice. Minus 81 on each side. You get 1600 equals b squared, and b equals 40, right? Because that's the square root. That was nice. So we know that b, this value over here, okay, let me erase that. I just found that this value is 40. I don't know why yet, but slowly get to that. So let me erase that. Erase that because I don't need it. So I need to find the big information. Okay, so I have all three numbers. So let's find x. So with x, I have this triangle, where this is x, this is my 90 degree, and this is 9. So, 9. So I'm going to use this other triangle over here, this triangle, where this is my 9 degree, this is 41, this is 9, and that's 40. So, x, my hypotenuse on the small triangle, corresponds to 41, which is the hypotenuse on this triangle, as 9, which is the second to largest side, and that's going to be the second to largest side on that side is going to be 40. Right? This is so 40x equals 369. I think. Divide by 40, divide by 40, and x is going to give us a nice ugly number, 9 point something, 9.225. Ugh. Let's just write 9.23. Yuck. And that's x. 9.23. So my y value, the y value, we're going to use the big triangle. Right, so the big triangle looks a little bit like that. Right, so the big triangle, this is the 9-degree angle. No. We use a small triangle again. Sorry. And this is y. This is 9. And I'm going to use that same triangle. Sorry. I erased everything. So this is 9 degrees. This is 9. The biggest side is 41. And this is 40. Okay. So, and actually this is 9.2. On the small triangle, y, which is the short side, must match the short side of this, which is also 9. Right? This y here and this 9 are the same side. And then let me pick this 9 because I don't want to deal with decimals. But this 9, which is the second to largest, matches up with this one. So this 9 and this side matches up with 40. So we got 40y equals 81 divided by 40 divided by 40, and y equals 2 point something. 81 divided by 40, and we get y equals 2.025. Yeah. Or 0 is 2.03. How am I doing? Okay. And the last one. Whew. Right away we can find any information that I can find. I can find this guy right here, right? So this, and let's call that z. So z right now is the square root of the product of 20 times 4. And we can write that as 4 square root of 5. To do all that stuff. Remember, 4 becomes 4 times 5, right? 4 times 5, so square root of 4 is 2, another square root of 4 is 2, and 2 times 3 is 4. So z here, this guy here, becomes 4 square root of 5. Now you're free to, do whatever you want. So, highlight this. Let me highlight this. If I want to highlight this triangle, I'm going to work this out. Because I have two of the values. So here's my 9 degree. I have this value, and I can find x using the Pythagorean theorem. So 6 squared equals a squared equals b squared. C squared, c is actually the x, right? Right, this is c. So, and the other two are a and b. So c squared, a is 4 square root of 5 to the second power, plus b squared, which is 4 to the second power, right? So c squared equals 4 squared is 16, and 16 times 5 is 80, right? So 4 to the second power is 16. Square root of 5 is going to come out, right? It's going to cancel out. I'm going to have 16 times 5, which is 80, plus 16 again. C squared is square root of 96, and c is the square root of 96, like I said. And can we break 96? You can write 96 in a nice, that'd be 2n, I don't know, 48? Yeah. 2n and 4, 4 and 6. And that's 2 and 3. So square root of 96, I can rewrite that as the product of 16 times 2 times 3. And that ends up being 4 square root of 6. So this guy becomes 4 square root of 6. So now we have a triangle. Oops. Now the other triangle here, this one, and let me put it in green, I guess. This big triangle, green. This big triangle over here, again I can use the Pythagorean theorem. That's the beauty about right angle triangles. And in that triangle, this big triangle, this is my 9 degree. This whole thing is 20 plus 4, which is 24. This side here I just found, which is 4 square root of 6. And my y, I need to find out. So again, Pythagorean theorem, c squared equals a squared plus b squared. My c I have, right, my c is my hypotenuse, and this is a and b. So c squared is 24 to the second power. A is going to be y, or a is going to be a squared, and b is going to be 4 square root of 6 to the second power. And I'm going to change colors. 24 squared is, I have no idea again, is 576. we get 576 equals a squared plus, and let's see, 4 square root of 6 of 4 square root of 6 to the second power becomes, well, 4 to the second power is 16 times, and the square root of 6 to the second power, remember this cancels out, becomes just 6. So 6 times 16 is 96. Then we're going to subtract 96 from both sides, and that's going to give me 480. All right, 576 minus 96 equals, yeah, look it up. 480, a squared, take the square root of that again, a equals the square root of 480, which, let's leave it in radical form. So 480, I can change 480 to 48 times 10. 48 is, nice numbers, 8, 12, 4, 6, and 8. This is 2 and 5. 16 times 30, or 4 square root of 30. Can I change the 30 into anything? Hang on a second. 16, 1630 is, so 30 is 215, 15 is 25, no, 16 square root of 30. So end up being 16 square root of 30. And I just want to confirm that. So square root of 40, so I take the 480 and I take the square root of that. It's going to give me 21.91 rounded. And if I did square root of 30, and then multiply that by 16, I don't get the same answer. Where did I mess up? I know I'm not going to waste your time. And this is square root of 480. Unless I did something majorly wrong, and you guys can figure out what 480 equals. Hang on. 480 is the same thing as 6 times 8, which is 48 times 10, right? And then 8 times 2 is 16 times 30. Sorry, I meant to say that this is the same thing as 4 square root of 30, and that was my mistake. 480 is the same thing as 4 square root of 30, because I can write 480. That was my mistake, sorry. 480 can be written as 16 times 30. You take the square root of 16, you get 4, which is my 4 here, and the 30 stays inside, and that would be the same. Okay? Done.